today we're going to talk about different functions and their graphs and kind of just get into the introduction of these. In our next section, we're going to get more into maybe some slightly more complicated pieces, but here we're just going to be doing the introduction. So let's start by talking about what is a relationship. So a relation is any set of ordered pairs. That means anything x, y, okay? So an ordered pair is also known as a point. It's called an ordered pair because the order matters, so x has to come before y. It's called a pair because, well, it's two things. All right? The set of all first components, or inputs, and in my example of x, y, this would be my x's. Okay, the ordered pair is called the domain, and the set of all second components, or outputs, which again in our example of x, y is going to be the y's, is called the range of the relation. So keep in mind a relation can be any relationship between two values, okay? But it doesn't have to be a specific one. Now, this should make sense because when we think about relationships, you can have a relationship between two people, whether it's a good relationship or a bad relationship or a neutral relationship, it's still a relationship. Now, let's take a look at this example here and see if we can't find the domain and the range of the relation. So you'll notice that I have these lovely squiggle brackets here. Okay, so squiggle bracket and squiggle bracket. We use these when we are writing a list of numbers. Okay, so these are how we define a set of numbers. So in this case, we have a set of points, and we want to find the domain and range of each one. So one of the things I want to point out to you as well is that a domain does need to be in order from least to greatest, as does a range. So we want to look at all the input values, or in this case, the x's, and use those to find our domain. So I have a 0, a 10, a 20, a 30, and a 40. And that's already in increasing order. So voila, our domain is squiggle bracket, 0, 10, 20, 30, and 40. On the other hand, our range is going to be made up of our y values, or our outputs. So when we find our range, we're going to be using our y values. And you'll notice those are not automatically, they're not currently anyway, in the correct order. So we want to start by finding the smallest value. So it would seem that the smallest value is 6.7. And then 9.1 comes after that, then 10.7, 13.2, 21.2. So it's going to start at 6.7, then go to 9.1. And then after that, the rest is in order. So is that in the correct order right now? Nope. You would need to swap the 6.7 and the 9.1. Fun fact. So a function is a specific type of relation, okay, where all of the things from the domain to the range function so that each element in the domain corresponds to exactly one element in the range. So for each input, there is only one output. Or for each x, there is only one y. Okay? So for each input, there is only one output. Okay, so inputs x's, outputs are y when we're talking about x, y. Okay, note that I say input and output and not just x and y because sometimes we'll have other letters involved instead. So let's take a look at this relation and decide whether it is a function. So the number 1 only goes to 2. The number 3 only goes to 4. The number 6 only goes to 5, and the number 8 only goes to 5. So for each x value, I'm only getting one y value. Now, you'll notice that there are 2 of the same y value here, but the rule is not for each y value there's one x. it's for each x, there's one y. So the fact that the y is repeated is not a problem. Just the x cannot be repeated. Okay, so in this case, we have no problem. We have no ordered pairs that repeat the x value. Therefore, it is a function. Da, 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 da. Now, if we want to write functions as equations, we're going to use something called function notation. And we're going to say y equals f of x. Okay, so if we have an equation that's solved for y, all right, and it passes the definition of a function, then we can write it as y equals f of x instead. All right, so let's take a look at whether or not certain equations can be functions. So let's see. Can this function, can this equation be a function? All right, so what we want to do is we want to solve for y and then see if I plug in an x value, am I going to get one y value or more than one? Because if I can only ever get one value when I plug in an x, then it's a function. But if I can get more than one, then yeah, that's not a function. So let's start by subtracting the x squared from both sides. So we did minus x squared, minus x squared. Then we need to get rid of the exponent because we're trying to get y by itself. So now I want to take the square root of both sides. But just like when we take the square root any other time, like when we completed the square, we have to account for both the positive and the negative square root. So for example, if I were to take the square root of 9, I'd get plus or minus 3. Well, here I have plus or minus the square root of 1 minus x squared. So is this a function? Well, nope. If I plug in an x value, I'm going to get both a positive and a negative answer. Therefore, it is not a function. So, for example, if I have x equals 0, I could get 1, or I could have 0, negative 1. And so for that x value, there's more than one y value. Not a function, therefore, I can't write f of x equals. So, function notation, f of x. Or you could say f at x, but I'll generally be saying f of x represents the value of the function at the number x. So I have like f of x is 4x plus 1. Then f of 2 is 4 times 2 plus 1, which is 8 plus 1, which is 9. So the idea is that I can now take notes and write what I'm doing so much more clearly because I can see that I'm finding the function at 2. There you go, when x is 2. And one of the things I want to remind you of, I want to keep pointing this out, y equals f of x. So now all we're doing is instead of y equals, we're writing f of x equals. That's it. That's the only difference. So let's try evaluating this function at f of negative 5, okay? So first of all, I write f of negative 5. I can't write f of x anymore because now x equals negative 5. So do not write f of x equals for this line. It has to be f of negative 5. And you can't just write an equal sign either because you're finding something else than what you started with. All right, then I'm going to plug in negative 5 everywhere I see an x. Now you're going to notice that I put parentheses here around my negative 5. That's because negative 5 in parentheses squared is not the same thing as negative 5 squared. So remember that when you're plugging in negative 5, you have to plug it into the x spot, means you have to have parentheses around it. Now, negative 5 squared is 25. Negative 2 times negative 5 is positive 10. And I carry down my plus 7. Now when I add all of those together, I get 42. Ta-da! F of negative 5 equals 42. Again, the big thing here is that when you substitute negative 5 in for every x, if you don't put the parentheses in the right spot, you will have a problem because it will not give you the same answer as if you don't put them, okay? All right, so let's talk about the graph of a function. So when we say the graph of a function, we really mean the graph of its ordered pairs. So a lot of times we write this as a t-chart. So if I had a t-chart that looked like this, okay, this is saying the point -2, 4, the point -1, 1, the point 0, 0, the point 1, 1, and the point 2, 4. So note that the t-chart is just a table of values that go with your ordered pairs, okay? So let's try graphing the functions f of x equals 2x and g of x equals 2x minus 3 in the same rectangular coordinate system. And they want us to select integers for x starting with -2 and ending with 2. So if I have x and f of x for one t-chart, I'm going to fill it in from -2 to 2. And if I have x g of x, I am also going to do that one from -2 to 2. So I'm going to start by plugging in -2. So f of -2 equals 2 times -2, which is -4. F of -1 is 2 times -1 is -2. F of 0 is 2 times 0, which is 0. F of 1 is 2 times 1, which is 2. And f of 2 is 2 times 2, which is 4. Now, go ahead and fill in our other t-chart, making sure to show your work with function notation. If you need to pause the video, go ahead and do that now. Now, when you've plugged this in, you should get -7, -5, -3, -1, and 1. And so those are your values for g of x. So we can now graph these on the same coordinate plane. That means on the same piece of graph paper. Okay? So f of x equals 2x. We start by plotting the points that we found. Okay, and so I found -2, -4, -1, -2, 0, 0, 1, 2, 2, 4. Okay, so we graph these the normal way. And then using our g of x, we're going to also be able to plot our graph. So you'll see that these two functions are both lines of slope 2. That means they're parallel. But it turns out that g of x is f of x shifted down 3. So they're actually really similar functions. Okay? Now, let's talk about how to tell if something is a function if we look at it on a graph. So if we use the vertical line test for graphs, it's just an easier way for us to think about using the points. So previously we said for every input, there's only one output. But again, looking at the graph, we can kind of skip thinking through it that way and go straight to the vertical line test. So if any vertical line intersects a graph for more than one point, then the graph is not a function of x. But if we can only ever draw vertical lines that go through one point or fewer, then it is a function. Let's take a look at what that means. Okay, so let's start with this one. Is this a function? Well, can I draw a vertical line that goes through more than one point? Yes, I can. And because I can, this fails the vertical line test. So this is not a function. Okay. Then we have this graph here. Is there anywhere I can draw a vertical line that goes through more than one point? No, there is not, because you're going to, no matter where you draw that vertical line, it's going to go through one and only one point. So it is a function. Note that for me, if you were to tell me on a test, for example, that you had something that wasn't a function, you would have to show the vertical line where it fails the vertical line test. okay? You need to draw that on your graph. If it is a function, you do not show your vertical line. You don't have to worry about it, okay? So again, you only draw the line as proof why something is not a function. So let's take a look at this graph here. So this is a graph of T cell count in HIV infection. So the time after infection is on the x-axis and the average T cell count is on the y-axis. So I want to use this graph to find f of 5. Okay, so let's see. 5 is my, well, this is f of x. Okay, so 5 is my x. So I go to where 5 is on the x-axis, and I say, okay, f of 5. I know y equals f of x, so it's asking me for the y value. So when x is 5, y is 400. So f of 5 equals 400. Since this would be part of a word problem, we're going to answer our question in a sentence. We're going to interpret what this means. We're going to say 5 years after infection, the average T cell count per milliliter of blood milliliter of blood is 400. There you go. That's a sentence that explains what f of 5 means and what its value is. So now let's find domain and range from a graph. So we're going to look and see for all the inputs or the x values for domain, and we're going to find all the outputs or y values for the range. Note that we're going to be using what's called interval notation. That means we're going to use parentheses and or brackets. Okay, parentheses are for things that are not included. Okay, and that'll be things with like open circles. And brackets are for things that are included, and those are going to be like filled in points. Let's look at some examples to see if we can't clarify what I mean by that. So let's take a look at this one. You're going to notice that we have two endpoints for this graph, and domain is going to be the x values. Now these endpoints are filled in. They're closed circles. So I know I'm going to be using a bracket for both of them. Now domain is from left to right, and because it's left to right, I go and I find the leftmost x value. So notice here that it goes from -2 to +1. Okay, so that's my domain. Now on the other hand, my range goes from bottom to top. So we have the bottom to the top. You'll see it's still closed circle, so it's still brackets. But the lowest y value is 0, and the highest y value is 3. So that's our range. Now, try to find the domain and range of this one. Now, for the domain, I can see that it goes from -2 to +1. But because I have an open circle here, I'm going to use a parenthesis. And if I have a closed circle here, I'm going to use a bracket. So that tells me -2 to 1. Now, the range, which is again from bottom to top, okay, is going to be from -1 to 2. In this case, the bottom one is closed, so that's a bracket, and the top one is open, so that's a parenthesis. Now, you're going to notice that on the previous slide and this one, we have a different format of answering the question that pops up underneath, and I do apologize for that. And this is inequality notation, okay? What you see here. So This is x such that negative 2 is less than x is less than or equal to 1. Okay, so this symbol here is such that, and if you remember, I told you the squiggle brackets were the set of. So the set of x such that negative 2 is less than x is less than or equal to 1. Now, you can write your answer that way, but what I've discovered is that there are a lot more pieces to accidentally forget, which is why you're seeing that I'm sticking with the parenthesis and bracket method, which is the interval notation. Okay, and you'll see y is negative 1 is less than or equal to y is less than 2, okay, which again can be simplified by writing it as the bracket negative 1, comma 2, parenthesis. So let's identify intercepts. So x-intercepts are where we cross the x-axis. That happens when y equals 0, okay? Y-intercepts happen when we cross the y-axis, and that happens when x equals 0. So if you're looking at the graph, you can look at where it crosses the axes. If you're having to do it algebraically, you can substitute y equals 0 in for the x-intercept, and you can substitute x equals 0 in for the y-intercept. So please know that you can only have one y-intercept for a function, but you can have more than one x-intercept. Okay, you can actually have no x-intercepts as well, fun fact. But you're allowed to have multiple, whereas you cannot have more than one y. So let's take a look at this graph here. I see that it squiggles. I see that it crosses the x-axis. How many times do you think it crosses the x-axis or touches? I see 3. And how many y-intercepts do you see where it crosses the y-axis? I see 1. So let's go ahead and identify these. All right, so I see negative 3, 0, negative 1, 0, and 2, 0. Those are my x-intercepts. Note that intercepts are written as points, okay? MyMathLab may or may not have you write them as points in your answer just for simplicity, but make sure that you write them as points on your paper and on your tests, okay? Because they are, in fact, points. Notice also that the y value for each of these is 0, okay? Now let's find the y-intercept. So I look over there, I try and find where it crosses the y-axis, and I see that happens at 0, negative 6. So this is how we're identifying intercepts using the graph. So let's do some practice problems. Go ahead and determine whether this is a function and give the domain and the range for it. So is it a function? What is the domain? What is the range? So 1 only goes to 3, 6 only goes to 4, and 7 only goes to 7. There's no repeated inputs, so there's no problem. Yes, it's a function. Okay. The domain is the set of, note the squiggle bracket, and that's a pretty ugly one, I apologize. But the squiggle bracket, okay, is going to be in order, 1, 6, 7. The range is going to be the set of, squiggle bracket, all the y's. So that's 3, 4, and 7. Make sure that you use the squiggle brackets because it's a list, all right? And you also put them in order from least to greatest if they're not already. Evaluate this function for negative 3 and then pause, all right? And we'll check that. And then we'll go through what it is for x plus 8. Okay, f of negative 3 equals negative 3 squared minus 4 times negative 3 minus 6. That's 9 plus 12 minus 6. And that is going to be 15. So f of negative 3 equals 15. Now, f of x plus 8, we're going to do the same thing. We're going to replace every x with x plus 8. The difference here is that when you square x plus 8, you're going to have to write it out twice and FOIL it. if you don't FOIL it and you just try to distribute the negative, you're making an error. You can't actually, or distribute the exponent, sorry. You can't distribute an exponent to a sum. You have to do the FOILing, okay? So go ahead, sorry about that, and try to FOIL, distribute, and combine like terms to get a final answer. Okay, so when I FOIL, I got x squared plus 8x plus 8x plus 64. Then I distributed my negative 4, and I got negative 4x minus 32. And I carried my minus 6. So I get that f of x plus 8 equals, let's see, x squared plus 12x plus 26, 32. Yeah, 26. There you go. Now let's go to this slide. Take a look at this graph and find the value of f of 7. Okay, so f of 7, remember this is f of x. So we're saying x equals 7. So x equals 7 right here, all right? And remember, y equals f of x. So we're saying y equals f of 7. What is the y value at that point? Well, it's 0. Note that the point is 7, 0, means that f of 7 equals 0. You cannot write the point in the blank. You can only write the y value. Now, take a look at this graph and see if you can't find all the answers here. The domain, the range, the x-intercept or intercepts, the y-intercept, and f of 1. So the domain, since the leftmost point is 0 and the rightmost point is 3, is 0 to 3. The 0 is a closed circle, so it's a bracket. 3 is an open circle, so it's a parenthesis. Now the range, the lowest y value is negative 4, and the highest is 5. The lowest one has a bracket, and the top one has a parenthesis for the same reason, closed and open. Now, the x-intercept is where we cross the x-axis. We cross the x-axis right here, and that is at the point 2, 0. The y-intercept is where we cross the y-axis. Well, that happens right here. That's 0, negative 5. Again, notice that I'm writing those as points. Also, I want to clarify something because a lot of people get this confused. A and B, the answers for domain and range, are intervals. Okay, this is the interval of x and the interval of y. Whereas the answers for C and D are points. So while they look the same, they are not the same. Okay? Now, f of 1. If we look over here, we find x is 1. And then we say, okay, right here is the point 1, negative 3. So f of 1 equals negative 3. Great job.